Hey, have you ever had this brilliant idea for a science project, but then you kind of get stuck trying to turn it into a real winning experiment? Yeah, you are not alone. Today, we're going to pull back the curtain on one incredibly powerful tool that's basically a blueprint for success. It's going to make your project's logic completely bulletproof. Let's dive in.
So here's our game plan. First, we'll build something I like to call the logical bridge. Then, we'll use that bridge to put together a super strong hypothesis and, later, to defend our final conclusion. After that, we'll get into how to spot and dodge some really common logical traps. And to wrap it all up, I'll give you a simple checklist so you know your project is ready to go.
I mean, this is the big question, right? How do you actually get from a cool general idea like, I wonder if temperature affects rubber bands, to a really specific, measurable, and, defendable experiment? Well, the answer starts with building a rock-solid foundation.
And that foundation, that's what we're calling the logical bridge. Think of it as the secret weapon that connects a big, general scientific idea directly to your specific project.
Okay, so this bridge has a technical name, a syllogism. Now, I know that word might sound a little intimidating, but it's actually just a really simple, clean way to use deductive reasoning. It's how you take a big, known scientific rule and apply it directly to your experiment, creating this perfect logical framework for the whole shebang. And the beauty of this whole thing is its simplicity. Seriously, every solid, logical argument is built with these three parts. You've got your major premise. That's the general rule you find when you're doing your research. Then the minor premise, that's your specific experiment. And finally, the conclusion, which is just the logical result of the first two. And guess what that conclusion is? Boom, it's your hypothesis.
All right, so let's actually put this tool to work. We're going to use this three-step blueprint to build a completely rock-solid hypothesis, right here from scratch.
Okay, step one, the major premise. This always comes from your background research. It's a widely accepted scientific fact. In this case, we know that, generally, all plants need sunlight to live. Simple, right? We're starting with what we know.
Now for the minor premise. This is where you connect your specific experiment to that big general rule. We're not testing all plants in the world, we're testing this specific bean plant. So our minor premise is just that. This bean plant is in fact a plant.
And now for the magic. If it's true that all plants need sunlight, and if it's true that our bean plant is a plant, well, then the only logical conclusion is that our bean plant needs sunlight. And just like that, you've created a strong, logical, and perfectly testable hypothesis for your project.
You know, you've probably been told a million times to write your hypothesis as an if-then statement. Well, now you know why. That whole if-then structure is really just a more conversational way of laying out a syllogism. If a bean plant is a type of plant, then it will require sunlight to grow. See? You've actually been using this powerful logic all along, maybe without even realizing it.
Let's run through this with another example super quick. Let's say you're testing rubber band elasticity. Your research, that's your major premise, tells you that heat messes with the polymer chains in rubber. Your specific case, the minor premise, is that you're going to heat up one group of bands. So the logical conclusion and your hypothesis is that the warm bands will stretch more than the cool ones. See? The pattern is exactly the same no matter what your topic is.
Okay, so we've used logic to get our project started. Awesome. But its job is not done yet. Now we're going to use that exact same tool to defend our results at the very end.
So when it's time to present your findings, a really powerful way to structure your conclusion is something called the claim, evidence, reasoning method. It's simple. First, you make a claim about what you found out. Next, you present the evidence. That's your data, your proof. And finally, you give your reasoning, the explanation for why your evidence actually supports your claim.
And hey, take a look at that reasoning step. What do you know? It's our logical bridge again. You're literally using a syllogism to connect your evidence back to the big scientific principle you started with. This is so crucial. Logic isn't just for building a hypothesis. It's the tool you use to justify your entire project from beginning to end. Okay, now for what might be the most important part of all, quality control. Because even a strong logical bridge can have some weak spots. So let's look at a few common logical fallacies or traps so you can make sure your project avoids them completely.
The first rule is super simple. It's the rule of three terms. A valid, clean syllogism must have exactly three distinct ideas. So in our plant example, those were plants, sunlight, and bean plant. Sticking to exactly three keeps your argument focused and clean.
Now, the most common trap people fall into is called the undistributed middle.
It sounds really technical, I know, but it just means your connecting term is way too vague. For example, what if you said, all winning projects are well prepared? My project is well prepared, therefore, my project is a winning project. You see the flaw there? Lots of things can be well prepared without being winners. That connecting idea just isn't specific enough to guarantee the conclusion.
And here are a few other quick traps to watch out for. A big one is overgeneralizing. So if your experiment shows that your one bean plant didn't grow in a dark room, you can't just conclude that all plants everywhere die in the dark. You can only conclude what your data actually proves. Another one is confusing cause and effect. Just because your plant grew taller on the same day the room got warmer doesn't automatically mean the heat caused the growth. You always have to ask yourself, could something else be going on here?
All right, let's pull all of this together into a final, simple tool that you can start using right away.
So, before you finalize your project, run it through this checklist. Just ask yourself, do I have exactly 3 clear terms? Is my connecting term specific enough? And does my conclusion actually follow logically from my premises without overreaching? This simple check can honestly be the difference between a pretty good project and a truly great one.
So, if you remember one thing, remember this. The syllogism isn't just some fancy vocabulary word. It's your blueprint for building a great hypothesis, it's the tool for structuring your entire argument, and it's your absolute best defense when you're presenting your conclusions.
Mastering this one simple structure will elevate not just your next science project, but honestly how you think about problems in general. It really empowers you to build these clear, convincing arguments from the ground up. So the only question left is, what logical bridge will you build for your next big idea?